Example 5.14 shows us the first application of Hess's law, where I'm trying to make this reaction that's shown on the paper out of the reactions that are given below. So you will want to have the slide pulled up so you can follow along. I have 4 reactions that I can start with to solve this problem, and a tip is to choose a reaction where you know where you want those things to go. So that first reaction that's listed, for example, with HCl going from gas to aqueous, I don't know how to use that yet because HCl doesn't appear in my overall reaction up here. So rather than start with that, I'm going to choose the second reaction. The second reaction with hydrogen and chlorine forming HCl. I like that reaction because that's the only thing that contains chlorine, Cl2. And I know that I want chlorine to be a reactant. So I'm going to take that second reaction that's shown from the information on slide 90, okay, and I know that I like chlorine to be on the left. Okay. So H2 gas plus Cl2 gas goes to 2HCl. Okay. I like that with delta H equals negative 185 kilojoules because chlorine has matched up. I want it to be on the left, it is on the left. Okay. But it doesn't have the right number. I need 3 chlorines. So I'm going to multiply this whole reaction by a factor of 3. Give me 3 H2s, 3 Cl2s. Okay, 3 times 2 is now 6 HCl's, and my delta H, right, is now no longer negative 185. I multiplied my reaction by 3, so I need to take my negative 185 and multiply that by 3 as well. Okay, so that tells me I've got negative 555 kilojoules. I've used that reaction. I've got my chlorine. That's good. Let's focus on getting my aluminum where I want it to next. There's only one reaction that contains aluminum, okay, and that's the fourth reaction, the one all the way on the bottom. It's got aluminum where I want it as a reactant. Okay, so I'm going to write that reaction also as it's shown. 2Al solid plus 6HCl aqueous goes to 2AlCl3 in the aqueous form plus 3H2 in the gaseous form. And that's good. I matched up my 2 solid aluminums. At first glance it looks like I matched up my AlCl3 as well, but I didn't because notice this one's aqueous. That one was a solid. Okay. My delta H for that reaction as it was written is negative 1049 kilojoules. So I've got my aluminum where I want it. I got my chlorine where I want it. I don't have the right AlCl3. So I'm going to take advantage of the third reaction that's provided in the information table, which is taking aqueous aluminum chloride to form solid aluminum chloride. And that delta H is equal to positive 323 kilojoules. But notice, right, I want 2 of them. So I'm again going to double this reaction. And if I double the reaction, I have to double that. 323 times 2 is positive 646 kilojoules, pardon me. Okay. So now I want to take a little inventory of everything I have going on, okay? Because notice when I introduced my solid aluminum chloride, I did myself a favor. Those 2 AlCl3s that are aqueous over here are going to cancel out the 2 AlCl3s over here that are aqueous on the right. Remember, if things have the same chemical identity and are in the same phase, we cancel them out. So these will go away. The same thing is actually happening with my hydrogens. 3 H2s in the gaseous phase here, 3 H2s in the gaseous phase there, which is a good thing because H2 is not appearing overall up here. But if I stop now and I look at my reactants and my products, I've got those 6 aqueous HCl's on the reactant side, and these 6 HCl's on the product side, which I actually forgot to fill in gas phase for those, because otherwise they may have canceled one another out. but those which came from reaction 2 are in the gas phase, so they can't cancel these that are in the aqueous phase. And here is where I have to take advantage of reaction 1, okay, which is HCl in the gas phase going to HCl in the aqueous phase. That delta H is equal to negative 74.8 kilojoules. But I don't just need one of these to cancel those guys out. I need 6 of them. So I multiply this whole reaction by 6. I multiply negative 74.8 times 6. That gives me negative 448.8 kilojoules. And notice every time when I've been doing math, I've crossed out the old numbers just so I don't mistakenly add them in later on. Okay. Now these 6 HCl's in the aqueous phase that are on the products cancel out the same thing in the reactants over here. These 6 gaseous HCl's on the left cancel out these 6 gaseous HCl's on the right. And if I go through and add everything up that's left, I have my 2 Al solid, my 3 Cl2 gas, okay, nothing left down here. So I go to my products, and the only one that's left is 2 AlCl3, solid phase, which I know is exactly what I want. Right? That's